acceleration. So average acceleration is your change in velocity over elapsed time. We denote that in formula by A with a line over the top. It's your change in velocity over change in time. We can use the delta symbol to show change in velocity over change in time. So let's work an example. A car accelerates along a straight road from rest to 90 kilometers per hour in 5 seconds. What is the magnitude of its average acceleration? Remember, magnitude is just how big. Let's list everything we know. We know it's at rest, so V1 is 0. V2 is 90 kilometers per hour. Comes from right there. You need to change that to meters per second. So 1,000 meters in a kilometer. Hour has 360 seconds. You have 25 meters per second. Your change in time is the 5 seconds. Using your acceleration equation, delta V over delta T, 25 minus 0, so make sure you're using the proper units, divided by 5, gives you 5 meters per second squared as your acceleration. So you're speeding up. It's a positive acceleration. Let's look at another example. This time you're traveling east, which will make the positive direction, and it slows from 15 meters per second to 5 meters per second in 5 seconds. What's the car's average velocity, or excuse me, acceleration? V1 is 15, V2 is 5. So you know it's slowing down. Time interval is 5 seconds. Our equation, delta V over delta T. Average acceleration is 5 meters per second minus 15. Be careful here. It's really common just to grab the bigger number and always subtract the smaller from the bigger. Look at your listed variables so that you select the right numbers. Here we have negative 10 divided by 5 to give you a negative 2 meters per second squared, which means the car is slowing down at a rate of 2 meters per second every second. Deceleration is when you have that negative acceleration. It's the magnitude of the velocity. Let's say that again. Deceleration is the magnitude of the velocity that's decreasing. So your velocity is going from 25 to 10. You have a decrease in velocity, and you're going to have a negative acceleration. Now, one thing that happens is that sometimes in a problem, they'll say a car is decelerating at a rate of 2 meters per second squared. But in the problem, you need to use that as negative 2 meters per second squared. So watch the syntax of the language as you work your problems.